Alright, chemistry, this is another sample problem coming at you from chapter 7, section 3. In this sample problem, we will be calculating the percent composition of copper 1 sulfide, the formula being Cu2S. Now remember, as modeled in the video lecture, which you should have already watched and taken the notes from before watching this, percent composition is essentially taking each individual element from a particular compound and identifying by mass what percentage of the mass is due to any particular element, right? Not any particular atom, but any particular element. And so you'll see here that there are 2 copper atoms per 1 sulfur atom, and that's going to come into play later on. One thing we do want to begin by calculating is the molar mass. So I will identify all of the elements present, copper and sulfur. I will use my periodic table over here to identify the average masses of the elements in question. Copper coming in at 63.55 grams per mole, sulfur coming in at 32.06 grams per mole. Next, I'm going to adjust for how many of each element is present per 1 mole. There are 2 moles of copper present per 1 mole of copper 1 sulfide. There's 1 mole of sulfur present per 1 mole of copper sulfide. So I'll multiply those out. 63.55 multiplied by 2 equals 127.1 grams. And then sulfur, 32.06 grams. And so by using this method, I've actually already generated the values that I'm going to use in the second part of this problem. So I do suggest that you use this same method in the future. But as far as where I am right now, I'm going to add these together. So 127.1 plus 32.06 come up with 159.16. Only issue here is that there's 1 digit past the decimal here, 2 digits past the decimal here. So I'm actually going to want to round that bad boy right there. And so the total mass of 1 mole of Cu2S is going to be 159.2 grams. Now the cool part is I'm going to take each of these values and I'm going to divide each of them individually by this 159.2 and then turn that decimal, which will be less than 1, into a percentage. And it's those percentages that I will record as my answers. So for copper, I have 127.1 grams. Let's compare that to the overall substance or compound at 159.2 grams. Then separately we'll do sulfur with 32.06 grams compared to 159.2 grams of the overall substance. So we put these into the calculator. This value comes out to be 0.7983668342, and then this value comes out to be 0.213819095. Again, I hope you're starting to get in the habit of considering your number of significant figures. I can only use 4 significant figures in either of these. I'm going to need to round to these spots. There we go. And then there we go. Now multiply by 100%, turn that into a percentage. And I'll have 79.84% copper. And I'll have 20.14% sulfur. One thing you'll want to do is to help you double check that you're on the right track is add all of your percentages up. Here, this is a binary compound. There's only two different kinds of elements, so there are only two numbers to add, but they should add up to 100. Now you'll notice that this actually adds up to 99.98, not 100 even. And that's actually okay, because you notice all of this, all of these values that we're actually leaving out. Not having an infinite number of significant figures to work with is actually going to hold us back here in terms of our overall precision. And so being off by 2/100ths is not actually an indication that we're incorrect. You're going to want to start rechecking your math or your procedure once you're getting to be like a whole percent off or more. If you're just a few hundredths of a percent off, there's no big deal. It's just an issue with significant figures and the rounding that you're forced to do because of that. So, what's the percent composition of copper sulfide? Well, it's 79.84% copper and 20.14% sulfur.